there I am over there at the back, look. And I'm still gorgeous, you know? And when we looked at this, of course, I have a brother in Canada, another in Belfast, and me here. It was like, my God, look at the haircuts. And then it was like, look at the fashion. And then this is my brother over here. I've got two brothers. There's one of them, and there's the other one. I'm in the middle, so I have middle child syndrome, among other things. And it was like, everybody's got coats on except him. He's got shorts on and a little tiny top. It was like, Mummy mustn't have loved you, you know. So anyway, so I was young once. So that leads into this talk quite well. So there we go. So I'm going to. This talk was meant to happen at PyCon Ireland 2012, and for various reasons I had to pull out of that conference. And I've had a few shaky years since, but now I'm back, and I thought I better update these slides. So I pulled out my pencil, and I said, okay, there we go. It's now nearly 30 years, and it's now the new date. So my story begins in 1987. This is one of the sad slides, because, well, maybe not so bad with this audience. If I was in next door, this would probably upset me more, but I always ask this. How many people, put up your hand if you weren't alive in 1987? Oh, the minority, not the majority, so I don't feel so bad. I've stopped asking my students this question because it's too depressing. So anyways, this is when it starts. I was a final year undergraduate doing computer science at the University of Ulster up in the north. And my dad, who worked for the Department of Health and Social Services, was involved in IT. And we were lucky enough to have a PC at home. In fact, he brought one home for us to play with, which I think is what we did. We didn't do anything else with it, although I did a little bit. And it was from a rather unlikely company. As well as making PCs, they made the Tomahawk cruise missile. They made the Apache helicopter. They also made the F-15 bomber. And they made the DC-10 passenger line. You know, so that qualified them perfectly to make PCs. The company is sort of still around because they got taken over by a much bigger company. But the clue is in the logo. If you look at the little logo there, that is the logo of Boeing, because McDonnell Douglas got taken over by Boeing. And all those products, they're all weapons of mass destruction except for the plane. And they're all still around. So this was, look, isn't it beautiful? Does that bring a little tear to some people's eyes? Because we all sat for hours in front of those things, but like that's what it looked like, sort of. That's actually, it's not a McDonnell Douglas, that's a Dell. I couldn't find a McDonnell Douglas image on Google Images. But look at the spec. Wow. 8088 chip, 512 KB of RAM. 16 color, not 16-bit monitor, 16 color monitor. It's like, ooh, WordPerfect 4.2. Who remembers WordPerfect 4.2? Like Control F2. You all know what that means, don't you? Because anybody that used WordPerfect knows what that is. So I was working on a database assignment in my final year of my, and I was working at home on it, and it wasn't really going too well. And I was doing stuff like this, which I know some people look at this and get a nice warm fuzzy feeling. Select supplier number, comma supplier ID from orders. Where purchase ID equals 1024 and policy number equals 42. Order by supplier number, group by supplier ID. I know some people love this, but back then I absolutely hated it. It was an awful subject. I didn't like databases at all, didn't like database theory, didn't really like the guy that was teaching it to us. And the reason I didn't like it was really silly. He pronounced policy number really funny. And it was like, all you could hear was this, when he said it, everything else went out of your brain and all you heard was the way he pronounced policy number. So I just didn't like, and I thought they were incredibly boring. I said, I just don't like databases. And of course, my dad was downstairs, I was upstairs, and he heard all the huffing and puffing and the banging and the shouting. And when he asked me what it was, I said, I hate databases. And here's what he said, and I can remember it clearly. He said, you better get used to it, right? He says, because the world runs on data. And then this is the exact thing that he said. He said, data is everywhere. Data is going to be big. My dad told me this in 1987, and like every other 20-year-old or whatever, I completely ignored him and didn't listen to him. And I could have trademarked big data back then, and I would probably have my own yacht by now. But no, I just ignored them, so it sort of went right over my head. But I sort of made a promise to myself, and I said, look, okay, I'm going to try and love data. I'll try my best. Now, not that type of data, okay? That type of data, and I know that some people are going to look at that and say, well, that big fat middle column isn't conforming to the first normal form, and to be honest with you, I still don't care. So anyways, this is the sort of stuff that I was going to do. And of course, doing database theory back then, cod and date. You know, cod and chips, cod and date. It was like, oh, and you had it just rammed down your throat, and they were, and the relational way was the one true way. I don't know what they did before the relational database model came along, but it was, they must have just used abacuses or something, because they didn't, there was like, data came along and it was the relational database management system. So you had COD 12 rules. Now you'll be lucky enough to know that I'm not going to go through those 12 rules because we haven't got all day. But the problems with SQL and with those sort of technologies, certainly back then and, well, for a good while after, was that they tended to be very big and expensive, right? They were as slow as molasses. The technologies were really poor, very performance poor. Everyone had, and sort of still has, their own standard of SQL. And they weren't really available on PCs back then until the wonderful day that DBase 2 came along. And not only was it a great little product, but it was absolutely fabulous marketing because there was no DBase 1. What they decided to do is they decided to call it DBase 2 so it would sound like it was a mature product and everybody would buy it. And everybody bought it. So DBase 2 was great, and it had a little programming language. It was high level, and it sort of was relational, and it was cool. And then along came, and I learned to love it, right? I learned to love it. Did a lot of development in it. Then along came DBase 3 and DBase 4. And I have a funny story. I can't remember if it was DBase 2 or DBase 3 that introduced the menu system. There was this menu system that you could use. I think it might have been DBase 3. But anyways, I used to work for, a long time ago, my first job after graduation was with Pricewaterhouse, who are now PricewaterhouseCoopers. They are known in Ireland as Craig Gardner because they're an accountancy company. I worked for them. And there was a guy, and his job was to manage the filing of all their client files. And he had a little DBase system, and he did it all. He was absolutely brilliant at manipulating that menu. It was all muscle memory. He could do it. You could go in and say, give me such and such a client's file, and he would go, click, 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 and he would pull up the entry. And when they moved him from 3 to 4, from 2 to 3, he nearly had a nervous breakdown because they changed the menu system on it, and all his muscle memory was completely gone. But that was good. But then DBase, if you remember, DBase sort of lost their way. I mean, it just sort of fizzled out. And then Borland came along, and Borland's big idea with Paradox was, if you remember, Paradox was that you didn't have to know SQL. So I thought this was great. You could use this query by example, which never really caught on that much, but it was different. And then Borland also sort of lost their way, which is really nice way of saying Microsoft killed them, which is what happened with both those companies. Although I no longer hated databases, I sort of continued to dislike them because I was having to learn all these things over and over again. And then the world entered the dark days of personal database management. Which, when people used it, they used to get faces like that. Right? We all learned to live with things, and that was one of them. So along came LAMP, like Linux, Apache, MySQL, and the P was, I think it was originally PHP, but then it became Perl, and then it became Python, then it became programming, so it could be whatever you want. And LAMP was great, because one of the great things about LAMP, for me anyway, was that you didn't have to use Access, so it was really plus, and it was multi-user database, MySQL, so it took off with it. But it sort of masked the bigger problem, and the bigger problem was that when you went for LAMP, you sort of opted by default for a relational database management system. So you went with SQL, or you went with MySQL, and whatever else. That was sort of the default, and you could get all these stacks, both on Windows and on the Mac. There was LAMP, WAMP, and MAMP, I think was the three things that you could, I think you probably still get them. But it just basically meant that everything was going to be relational, which is okay. But I'm a big one for, and I'm trying to always instill this into my students, that they need to choose the right technology for any given situation, as opposed to picking a technology for your project that you think might get you a job, But then if you fail your project because you picked the wrong technology, well, you're not going to get a job anyway, so pick the right technology. So I'm always trying to get that across as a message. So when I start to write a new program, I never say to myself, what algorithm do I need to use? I always sort of say, what does my data look like? Okay? And that's where I start. So here we have some beautiful Python data, right? So here we have, we've got a dictionary on the outside here, and inside the dictionary we've got all types of different things. We've got some strings, some numbers, we've got some one-element lists and multi-element lists, and this is nice. This is the sort of thing that Python programmers love, because we've got all this complexity in this data structure, and it's all handled for us automatically by Python. But if you take that data structure and you try to turn it into something that you can put in a database, specifically a relational database, like MySQL, it's a little bit harder. There's a bit of work that you have to go through to take what's in your Python program, convert it into something that goes into your MySQL database, and then get it back again. And I know there's tools, and people are sitting going, he's never heard of SQL Alchemy. I know there's tools, but at the most basic level, forgetting about Python, any programming language, getting something like that, which probably maps to your application requirements quite well, into your database, into your relational database, can be hard. And it gets worse if there's something like this, which is a list inside a list, inside another list, inside another list, and which is an awful database, an awful data structure. And who would ever pick something like that? I'm the fool that put that into chapter 1 of Head First Python, thought people would find it would be okay. Oh dear. I've been updating Head First Python for 4 years now. I've produced 4 new chapters, so that's a chapter a year. So I've told them I'll have it ready for next year. I'll have it ready for next year, I promise. It's not going to take me another 8 years, because they've had a lot of patience with me, but they won't have that much patience with me. And I'm on to my 4th editor, so I don't know whether it's me or them or both of us, but we're getting there. But anyway, something like that is even worse. Something where you've got an embedded data structure inside an embedded data structure, and that's worse, right? So we have a thing called an impedance mismatch, right? So an impedance mismatch is that the data structures in your program map poorly to the data structures, the data schema in your database. Okay, so how do we get what's in our program into the database and back out again? So I sort of thought, okay, I wonder where that came from. So I did a bit of research, and it actually came from Star Trek. So this is what happened. I'm not going to try a Scottish accent. I know the North isn't far off a Scottish accent, but I'm not going to try it. So I'm sorry, Captain, but I can't make it go any faster. We have an impedance mismatch. So when Kirk tells Scotty to sort it out, poor old Scotty collapses. And Kirk says, quick, Bones, do something, help Scotty code his ORM, because that'll solve all your problems, right? And Bones issues the now immortal line, damn it, Jim, I'm a DBA, not a programmer. Right? But it is so joking aside, it is a real issue for many programmers, right? It is. When you have a technology like a relational database management system, which forces you to do all your design up front, it can be a problem, right? First of all, you have to work out what you need to do with your complex data structure to get it into your database and get it back again, but you also have to design your database properly in the first place. And when you've got something like that, it can be hard, right? And it's much harder if you've worked with that data structure and you've got 30,000 lines of code, and then your user tells you that they want to add another field or change your database structure, and you end up sort of getting a sore head and you spend more time trying to think up reasons why you shouldn't do that change as opposed to actually doing the change, because it's hard. So then along came, so I was dealing with that for years, and then along came NoSQL, which was going to be the rescue to all of this. So we have a whole bunch of technologies, and there's just some of them. One of them I only just realized are upstairs, I think, in either this building or the next. And the idea with this was that it would solve all the problems that we had with our relational database management systems, especially if you were a programmer. So you got design as you go database technology, so you didn't have to design anything up front. You just start writing code. I like the sound of that, right? I mean, just start writing code. And there was less or absolutely no impedance mismatch. I mean, if you had data in your program, you could take that data and just shove it into your database, and your database could handle it. Wow. So bye-bye to SQL Alchemy and the likes, and all those other ORMs or technologies like that, and I could just talk to it almost directly. Also, they had better horizontal scalability, which is a problem with some of the relational database technologies, and support for distributed systems, which is a real problem for all database technologies, not just relational ones. So if you had something like that, that's the code in our Python data structure, you could wrap it in some code like that and not have to change anything. And that's a little bit of code that takes the information and throws it into a MongoDB database or collection or whatever they call it. And then lets us get it back out. And it just looks like Python because it is just Python and it just works. And I thought this was absolutely fabulous. And I think it is absolutely fabulous. So what actually happened was, a funny thing happened. I fell in love with the database technology. And I probably shouldn't use this line, but I'll use it anyway. I fell in love with a leaf. Right? So Mongo. I thought Mongo was terrific. I use it a lot. But it doesn't mean, of course, the fact that we have Mongo doesn't mean that we should just throw away the 40, like I know I've been at this for nearly 30 years, but there's like more years than that. There was a good decade before I started, even more than a decade before I started living at it. So over 40 years, we shouldn't just throw it all away and say, relational is bad, no SQL is good, let's go on. We just can't do that, right? We have to think about what is the best technology for the job at hand. And Polyglot persistence is this new thing. It wasn't a new thing a couple of years ago. Is the new black. So we know what polyglot programming is. We can't just survive on one programming language. We'd like to do everything in Python and forget about all the rest. But based on what you're doing, if you're doing a highly concurrent application, I tell people ask me how do you do that in Python. I say you use Erlang. If you're doing client-side programming in a web browser, well, really you have to use JavaScript. You just have to sort of tough it up and do it. So you have to be a polyglot programmer. So you can also have polyglot persistence, which is you use relational database management systems where they make sense. You use NoSQL where it makes sense, and you have something else, maybe some sort of hybrid thing, where it makes sense. Of course, a good example is the Google App Engine technology. They have a mixture of ways that you can get at the data. They will let you talk to it with like an SQL-like technology that they have. They have an API. They support MySQL as well. So there's a bunch of different ways to do it. So there's people who are working on this. Great book if you're into databases. This is a great book. It's a couple of years old now, but it does a really nice treatment of each of the available technologies that are out there. Well worth a read. Of course, the SQL community and the relational database management community aren't really taking this all lying down. I mean, they've got these upstart NoSQL guys coming in telling the world that we've all been doing it wrong for 40 years and we're doing it this way. So now we have the relational database management system sort of striking back, so the emperor strikes back. And we've got this notion of new SQL, which is scalable SQL technologies, high-performance relational database management systems, that deal with some of the problems that NoSQL is also dealing with. Who knows where this will all lead? I don't really know, but certainly the more choices, the better. So in summary, it's never been a more exciting time to be into data. There's lots, maybe there's too many choices, but there's lots of choices. I think that's good because you pick the right one for the right technology. One size fits all no longer applies. Data is the new oil. And if you don't believe me, believe the Beverly Hillbillies, who say if there's gold in them, there are queries. Thank you. We've a bit of time for questions if anybody has anything.
Thanks for the great talk. Do you think it's possible to write your code in such a way that you're insulated from the underlying data persistence layer and can easily migrate from one to the next? Is like ORM is one possibility, but it kind of ties you to relational. Like Java data access objects, where you introduce just a whole new layer inside your code. Do you think that's a reasonable approach, or?
I'd say most people are using SQL Alchemy with their technology, which shields you from having to know anything about SQL. So that's the approach that they took. Let's not force people to know about SQL. Let's provide them with an API. Is there something that allows you to have anything underneath that you just don't know about? I mean, some of the cloud technologies are taking that approach. You just don't know what they're using. Like, I don't really know what, if you look at Google App Engine's data store, I really don't know what they're using. I mean, it sort of can look, you can make it look like a SQL database, you can make it look like a NoSQL database. It depends how you put your data in and how you update it. But you can certainly, put a row of data into Google App Engine's data store with one particular format, and then in that same table or collection or whatever you want to call it, you can put in another row which is a completely different format, and it will quite happily take it. So you're shielded from that perspective. You just don't know what's underneath. but then you're stuck with Google App Engine. Not that there's anything wrong with Google App Engine, you're locked into that technology. So I don't know. I think it might come. We're not there yet, though.
What about something like Postgres 9, right? You can put in whatever you want in there now.
Yeah, I missed the talk across the way. I wanted because I was in here. So, I'm not as familiar with Postgres.
You can put JSON, DSON, you can put GIS, you can do queries that kind of look like SQL.
Okay, well, I'm going to check that out then. So I think that's great. Postgres is great, yeah.
What's your opinion on those data housing technologies that don't conform to the relational model?
Data housing technologies that don't conform to the relational model. I mean, do you know any one in particular?
The ones that came up.
Right. I mean, I think to get back to the first question. I mean, you probably want to get to the point where you don't care how your data is stored, right? I mean, but we're not there yet. But I think that if we're heading in that direction, it's good. So I mean, I would like to be able to just give my data to something and have it stored, and when I get asked to get it back, it comes back. And if it comes back in the same format that I gave it in, well, then I'm generally happy, because there's no extra work on my part from getting it into a format that the database can accept and getting it into a format that getting it into a format that my programming can accept. So if technologies are coming along, and I think there are, then good. Right?
What do you think of the current trend of NoSQL databases adding standard query languages?
Well, I think it's probably I mean, if you look at what App Engine did, they had this GQL, which was a stripped down version of SQL, and really what it allowed you to do is take an existing application that used SQL and port it relatively easily into App Engine, and I think that's what the rest of them are doing, is they're trying to offer people a route, instead of saying, like it used to be, oh, your technology is bad, our technology is fabulous, port everything over. Now it's like, okay, well, port over the bits and you can keep all your queries and we can run them too, and I think that's more of a migration strategy type thing, right? So I think we're going to see more of that, right? I think there was an attempt to have like a NoSQL standard language, but I don't think it really took off. And I think SQL is pretty deep-seated in a lot of people's brains, so it'll take a long time for that to be moved or taken out. Anything else?
Yeah, just point out one factual error.
Go ahead.
You said in your original statement that the one that wasn't the best weapon of mass destruction was the DC-10.
Well, yeah, it crashed a lot, right? But it's a sort of I thought about making the joke and thought, no, I'll just skip over that. But yeah, the DC-10 was it was the most used passenger airline in North America. I mean, it was they sold more of them than anybody else, and they flew more miles than anyone else. Unfortunately, because of that, they crashed more than everybody else because there was more of them. I mean, it's just if 90% of the cars were Fords, most crashes would be in Fords. So, but yeah.
They will say it's a bit not the 9 o'clock news to skip about heard to believe that pigs and even DC-10s
And fly, yeah, which is really bad taste. But there you go. All right, and on that bad taste note, thank you very much, folks.